All right, this is the final installation of the home security system replaced with the Pi, Raspberry Pi. Let's take a look inside. All right, here's the final installation. Now, it took some time to get to this point. From an idea to design to full implementation, it took about a month of off and on work. It takes time to get to this point. But it took me, like for example, it took me a day just to set the plexiglass, just get the plexiglass cut and drilled to hold these components in place, um, to mount these components in place, as well as mounting it to the box back here with that screw that then goes into the box and the wall. And from the previous video, if you remember, I had the existing system with the existing board in here. It didn't have any smart home technology. Everything was done with a keypad. So you had to program everything through the keypad. But now with the Pi, you can program all the software yourself. Also, that old system didn't even have a wire. It didn't even look like it had a wire hookup to call the police. Now this is the after picture, and I can make it do whatever I want because I control the software. If I want to call the police, ring a bell, email, or whatever. These are all the nice advantages of this type of setup. As you can see, I was able to put everything inside the existing box. I also had to move some of the existing wires. I put them off to the side here. These are some wires that aren't going to be used in the system. There were some extra wires, and there's the keypad wires. So I safely tucked them off to the side here, out of the way. Now I have two power supplies coming in here, right? So there's the one power supply for the Pi, and then there's this other power supply coming in through that hole that powers up the sensors. Now I actually had a problem with the Pi booting up here, but that was because the problem here with this Pi booting up was because I noticed that this MCP, you can see the LED on there, that NCP 230117 expansion board right there, that LED, it was really dim, it was really faint, and my Pi wasn't booting up. So I'm like, why is that happening? Well, that was because I had it wired up to the 3.3 pins of the Pi, and the 3.3 volts on the Pi is not designed to handle too much load. So instead, I hooked it up to my 3.3 volt regulator here, which regulates the power supply from the 5 volts, which boosts up to 800 milliamps. And that was enough to power these boards, these lights, all these lights on all these sensors up on the bottom here, and then up into this board. And that LED, once I did that, the Pi booted right up, and the LED turned to the right color. It wasn't fainted. It was a nice solid red color there. So that solved that problem, and that explains it. It just needs to have more power to that expansion board there, where all of these wires are going into. Basically, all the sensor input wires are coming into this board. So, and then those go into the Pi there, right there. So that was the only adjustment I had to make to that design, to my original design. I had to put this power bar in to hook up. So that power is coming from the 3.3 volt power supply regulator here. It was called a buck converter. I don't know if it really is a buck converter or not, but I just know it converts my power from 5 volts to 3.3 volts and gives me 800 milliamp. I just have wires coming in here, and then wires are going out to both the expansion board and then up to the optocoupler board, which then from there I just pigtail over to the remaining boards. So in other videos, I've showed you the design, but let's go ahead and run through this one last time here, design at a high level. So the blue and the gray wires are the power wires coming in, or I mean the sensor wires, sorry, the sensor wires coming into the optocoupler boards here, which you can see I just have them where all the pigtails are, all these wires, the red wires are going into the power supply up there at the top that I have up there at the top, those power bars. And then the ground is going to the common of the negative pole of this coupler boards, which then once the sensors are intact, the circuit's closed and lights up these LEDs, which then sends a signal down to here, down to the lower side here, which is where the 3.3 volt side is. And those wires come down into this expansion board right there, and then into those inputs. So that can serve up 16 inputs. That board can serve up 16 inputs, which then come into two inputs, basically the I2C ports of the Pi header here, the I2C ports. There's two ports there for I2C. I think they're called SDA and SCL on the header, and those are the blue and yellow wires going in, I believe. So then the Pi has the software set, and it detects when the input signals are going to ground, and that tells me a zone has been breached. So I explained a lot of this in all the other videos, but I wanted to show it all here as a final all installation, everything set up. So as you see, everything is lit up and armed. So I say, let's go ahead and give it a test here. Let's see if I'm gonna close zone 1. I'm gonna open up the door to zone 1, and let's see if this LED flips off, and then see if we get a notification. Right now I have it set up to notify my phone and Alexa. So we'll look to see if we can find a notification on the phone and on Alexa. Okay, now you can see that LED, there should be 4 LEDs lit up here on this board, the second board here. If you notice, that LED is turned off because I opened the door that this zone goes to. And as a result, there's no LED showing up down here either. This LED is turned off. That LED down there is turned off as well. So I should get a notification now that door has been opened. So as you can see, I've got a notification on my Alexa device. The blinking yellow light tells me there's a notification.
Security alert, office door opened on Monday at 2:21 p.m.
And that's what the alert sounds like. So that was Alexa notification telling me that the door was opened, and that was because I programmed it into the Pi to send a notification to Alexa. And that's pretty cool because you can do that with the Pi, and you can change all sorts of settings on it that way too. So you're like in a lot of control there. But I've also, as a note, I also color coded these wires with labels to match the colors of the bus wires. The bus wires you can't really see too well. The bus wires there, the yellow, green, orange, blue, purple. And I labeled them all with the zones. And then I also have a printout of all the zones with the colors and labels and where they go, where the sensors go, what zones the sensors belong to. I was also concerned about the temperature buildup inside of this closed box. With the Pi, there's a command in the Pi that you can run that'll tell you the temperature of the CPU. And so far, ever since I ran it, the CPU has been okay. It's varied around 101 Fahrenheit to like 107 Fahrenheit. So far, no problems. But I'll continue to monitor that and make sure that nothing gets too hot in here inside this box and things start to go haywire. But all in all, this proves an old security system can actually be modernized with the Pi. And this video series, I hope, showed you how to do that, or at least how I did that, and shows you how to replace an existing board with your own setup.